let's talk about some curve sketching. All right, we've been talking about the derivative, first and second derivatives, and how they affect a graph. And so now we're going to see how we can look at the graph of a derivative and know something about the original function. All right, now this is going to make your head spin a little bit sometimes, but hang in there. You'll get it. Just the key here is to keep in mind of what we're looking at. So this graph is the graph of f prime of x. All right. Remember that these are all functions. Okay. So when we are working with these graphs, the derivative is a function, and the original function obviously is a function. So, but we just got to keep in mind what these points resemble. All right. These points tell us information about the function. They tell us information about the derivative of the function. Okay, so this is the derivative. All right, so the graph here is the derivative of the function on this interval that we're able to look at. And so we want to find some things about the original function. Okay, so the first question here, let's find the increasing intervals for f of x. All right, so where is this the graph increasing? Not the one that we're looking at. Where is the graph of f of x, or the function itself, increasing? Well, we know that the function increases when the derivative, the first derivative, is positive. Okay, so where is the first derivative positive? Well, it's positive in here, in these areas here. All right. Get a little highlighter here. Okay, so there's some positive points, and there's some positive points. All right, so we want to use those three intervals there. Okay, so let's describe those intervals. We have from negative, what is that? -5. Okay, so we got from -5, ooh, orange, to -2. Okay, that's this interval right in here. And then we've got this interval right here, and that is from 0 to 2. We got positive derivative there. Again, positive derivative means the function is increasing. Okay, and that far right one is the stuff from 5 to 0, to infinity, actually, not 0. Okay, so there, those spots are where the derivative, this is our derivative, the derivative is greater than 0. That means the function is increasing. Okay, so the next question. So where is are the relative maximums and minimums? Okay, so let's think about what we know about the first derivative. When the first derivative is 0, then we get relative minimums and maximums. Okay, or possible relative minimums and maximums. Okay, so we have these 5 points where the derivative is 0. Okay, so remember that to be a minimum maximum, the derivative has to be 0, and we have to be changing from negative to positive, or positive to negative. Okay, so on this interval here, we have on the left, okay, we have some negative. The derivative is negative, and it changes to positive. So right here, it changes from negative to positive. All right, going from negative to positive in this area. Okay, so that point is going to give us, it's going to give us a minimum, because the function is decreasing, then it's increasing. Okay, so we want to find the zeros of f prime of x. All right, and so and specifically where it's crossing. So we have our minimums and our maximums. Okay? So that guy, what do we say? It's going from negative to positive. So from negative to positive, that's going to be a minimum. So that's x equals -5. Okay? Okay? And now over here, we've got another 0. We're going from positive to negative. These values are negative over here. And so the function f will be going up because we've got positive numbers. And we're going down to negative numbers. So that's going to be a maximum. X equals -2 at this point right here. Okay? Remember, we're not looking at this graph here. We're not finding minimums, maximums of this graph. We're finding minimums and maximums of f of x that we can't see right now. So maybe we can even think of a little graph here of f of x. Okay, so we know down here at -5, the derivative was going down, and now it's going up. And then at -2, it was going up, and then it's going down. So at -2, we had a maximum somewhere. Okay? At 0, notice that the derivative before 0 is negative. The derivative after 0 is positive. All right? So that's going to give us, so it was negative, now it's going back up. All right? So that's a minimum. So at 0 is going to be a minimum. And then we're going from positive numbers to negative numbers at 2. So at 2, there's another change. Positive slopes to negative slopes. Okay? That's going to give us a maximum at 2. And then, let's get this guy over here. We got one more. We're going from negative slopes down here. Oops. Going from negative slopes to positive slopes. Okay? So negative to positive there. Okay? And so at 5, our little record sheet here, that's going to be a minimum. Okay? Okay. So there's our minimum and maximum locations. All right? Now, if this, by the way, if this graph were to like bounce at some point, if we were to have the derivative and it, it comes maybe back around here and it bounces off the axis, okay? There, notice it's not changing sign, so it's not a minimum or a maximum, all right? That would be an inflection point there. So, all right, cruising along. At what intervals is it concave up? Okay, so concave up is when the derivative, the second derivative is 0. So we're looking for second derivative, I'm sorry, not 0, but greater than 0. Concave up, okay. So second derivative, now the second derivative is the slope of this graph. So we're looking at the slope of this graph, okay. When is the slope positive, okay? So when the first derivative is increasing, we're going to be concave up. So that's really all we're asking, okay? So that, let's write this down, when f prime of x is increasing, right? Okay, because in a graph, when for f of x, if we have somewhere where it is getting, the slope is increasing, that's concave up. Slope is increasing, that's concave up, okay? So the slope of f is increasing. Where are the slopes of f prime increasing, okay? That's going to happen at -infinity to 4. And we're going to approximate a little bit here because they're, if you look at these points, they're not right on there. But okay, so we've got that. Let's call that a value of 4. Oh, there's the value right there, 4.02. So we can call that 4.02. Okay. We'll round off. That's fine. And then going to this, let's see, from this value right here. So we're increasing right there. And so that's going from negative 1.112 to positive 1.112. Again, we'll just round off a bit. Okay. And then where else are we increasing? It's going down, and then here it's increasing there. Okay. So the slope's getting more positive. So that means f double prime is going to be positive. And so that's from 4.02, rounding off to infinity. Okay? All right. So, at what approximate x values do we have an inflection point? Now, an inflection point happens when the curve is concave up and then changes to concave down. Okay? So, for example, right in this area right here. Okay, so look at this part of the graph. The derivative is positive. That means our graph of f is going up. And these slopes are all positive. Okay, the second derivative, slope of this graph here, so the slopes are positive here because we're above the y-axis, and the slopes are getting steeper. So we're positive, and we're getting steeper. But at the value -4 here, right? At -4, all right? At -4, the slopes start to get less positive. They're still positive, so we're still going up, but we're getting less positive, okay? So on F, something like this is happening. We're getting more positive, and then we're getting less positive between those two values, all right? So that's our point of inflection, okay? So right at this peak, when f double prime of x is equal to 0, that's where we get an inflection point, okay? So that's what we're looking for. So f double prime is 0, and so the second derivative is 0, and that happens at x equals -4, and that happens at what do we got here? About x equals -1. Again, we're approximating right here. X equals +1. If you want 1.1, okay, 1.1, and down here at x equals 4. Okay, so that's when the second derivative is 0, and that's when we get an inflection point. All right, almost there. So now we're going to sketch a graph. Okay. Now we need an initial condition, so that's what this is. Assuming that f of 0 is equal to 0, sketch the graph of f, okay? If possible, we'll find the x values at which we get a maximum or minimum value, and we kind of already did. So, all right, so max and mins we got up top there. So let's graph this thing here, okay? We've already just done some rough sketches here. Now, it's not going to be super exact, so we're not totally worried about how high it goes and all that stuff. But we're given this assumption that f of 0 equals 0. So let's kind of work from there, okay? So we know that we've got some critical points here. So we know that at -5, -2, 0, and 2 and 5, those are our critical points. So something interesting is going to happen there, all right? So, all right. We know, let's use this idea right here, okay? So we know we're decreasing, and then we're increasing, and then we're decreasing, and then we're increasing, okay? And we should have a minimum when x is 0. And we're told that this is true, so okay. So let's make that a minimum. There's our point 0, 0. We know there's a minimum at 0, 0 because we're going down, then we're going up. Okay, so let's go ahead and do that. We also know that we have, well, let's just start from there, all right? So we know we're coming down into this. Okay, and we're going back up. That's a minimum, all right? So we know at negative 2, we're going to have a maximum. Again, we don't know. We don't know exactly how high this is, okay? But we know at negative 2, we're going to have some kind of maximum, all right? Cool. So we got a maximum up here somewhere, okay? We also know that in between there's an inflection point, and there has to be, because this is going to be a smooth curve. And so we knew here that at negative 1.1, right in between here, there's an inflection point, okay? So negative 2 is a maximum. We have that right here, okay? And then we're going to come back down around, and at negative 5 is a minimum, okay? So somewhere, again, we don't know if it's below the axis or above. Notice we never talked about zeros. But we know we have an inflection point somewhere in between here, negative 4, because it's got to change. We're going to come down and scoop around here. All right. And then since this is a minimum, we've got to go back up. And that's it'll never come back down. All right. All right. So let's see here. Let's keep cruising along. All right. We know that 2 is a maximum. Okay. So 2 is a maximum. So somewhere up here we have maximum. We don't know how high, but we just know somewhere up here. Okay. And so this curve is going to go up to some point. We also know that right here we had an inflection point at 1.1. So halfway in between here, roughly halfway, it's going to change from concave up to concave down. Okay? Pretty sloppy, but that's okay. If you wanted to make it look pretty, you could erase and clean it up. So then we're going to go down. Okay, we know that's minimum or that's a maximum, so we got to go back down. Okay, so somewhere down here, we've got an inflection point at 4. We know that we have a minimum of 5. Okay, don't know how far, right? But I know we got a minimum. Okay, now I give you one more clue here. All right, notice how this is all symmetrical. All right. These, we got negative 5 and 5. They're very symmetrical. That's a little bit of a clue that this graph is very likely going to be totally symmetrical. All right. So the left side and the right side will look the same. All right. So kind of this roller coaster effect going on here. So I have no idea how far down it goes, but we know it's going to go down. It may be below the x-axis. It may not. All right, so I'll put that down there just, okay. So there's features of this graph that we know and there's features that we don't, all right. We do know that this is a minimum at 0, 0, so if it's true that f of 0 is 0, then it has to look like this. We don't know that it actually dips below here. We don't know that, okay, but we could think some more about these slopes that might help us. But anyways, that's good enough there, all right? So again, we take the derivative, the graph of the derivative, and we can work through and we can figure out these important things. Zeros of f prime give us the mins and maximums. Okay, that's when the derivative are 0, right? Because that's when we would have these tangent lines of f that are flat, okay? By the way, we should label this F. Got to label these graphs, okay? F, and this is F prime, all right? So zeros gave us maximums and minimums, okay? It was concave up when F double prime is 0, okay? F double prime means that the slopes here are positive, okay? The slopes of F prime is F double prime, all right? So, and the inflection points came when f double prime is 0, the second derivative is 0. Second derivative is 0 at these points. And so that's where we got our inflections. All right? All right, there you have it. So keep working on it. I know going back and forth gets a little challenging, but you'll get it.